Hello and welcome everyone to MTRI's first August talk of our summer seminar series. My name is Luca, and I'm a research technician here at the Mosquito Research Institute, and I'm going to be your moderator for tonight. Before we begin, I would like to acknowledge, though, that the MTRI is located in, and we are meeting from Keswick, one of the 7 districts of Mi'kmaq, home of the Mi'kmaq people. We acknowledge the treaties of peace and friendship, and we thank the Mi'kmaq people for their generosity in sharing their homeland with us. For anyone that may be joining us for the first time tonight or that has not heard of the MTRI before, I would like to give a little bit of background about us. The MTRI is a research-based nonprofit organization located in southwest Nova Scotia, close to Keswick National Park and National Historic Site, and within the Southwest Nova Biosphere Reserve. Our mission is to promote, conserve, and sustain biodiversity in Keswick and beyond. Now I would like to introduce tonight's speaker, Taylor Swanburg. Taylor is a master's student and research assistant in Dr. Ferguson's lab at Acadia University. And tonight, Taylor will be sharing her master's research on mosquitoes in Nova Scotia and some of the results of her province-wide mosquito survey with us. Before we begin with the talk, I would like to remind everyone to please keep your mics muted. And if you have any questions, please just type them in the chat video window here on Zoom or in the Facebook Live chat. And we'll also have a dedicated question period at the end of the talk where you can ask your questions live. And with this, I would like to hand the seminar over to you, Taylor. Thank you very much.
Awesome. Thank you so much for introducing me, Luca. I'm going to jump into, like Luca mentioned, my master's research. So I've been doing a lot of surveillance over the last 2 years on the mosquito diversity in Nova Scotia. I just want to talk about a bit of my master's research, which I'm hopefully finishing up any day now. I defend 2 weeks from now. So you get a little sneak peek of my defense. So as we know, climate change has been kind of continuously impacting our environment, whether this is through more dramatic weather events, higher annual precipitation, and even higher annual temperatures. And this has a large impact on the mosquitoes that we see across the world. So most mosquito species, or I should say all mosquito species, are ectothermic, which means where they live entirely depends on the environment around them, specifically the temperature. So as we see global temperatures start to rise, we'll most likely see mosquito ranges expand towards the poles. So here I have just a bit of an interactive infographic where you can see as they use projected climate change variables that mosquitoes will start to expand northward into Canada. So Canada has historically been protected from many of the mosquito-borne diseases that we hear about across the world, and this is due to our very cold and harsh winters. So as climate change kind of reduces the severity of these winters and increases our annual temperature, we'll likely see more mosquitoes, more mosquito species, as well as more diseases that these mosquitoes can transmit. So this is this visual is for the specific species Aedes aegypti, which it's a really medically important vector species and is capable of vectoring diseases such as yellow fever, chikungunya, and Zika, many diseases we don't currently have in Canada. And I'm just going to zoom in a little bit here. And here you can see Nova Scotia is definitely in the path of many of these mosquitoes. So we'll likely be one of the first people in Canada to actually see these invasive mosquito vectors. So Canada has had quite a few invasive mosquitoes over the last 2 decades. I can't go over all of them, but I'll go over the really important ones, just to give us an idea of what invasive mosquitoes we are starting to see in Canada. So in the early 2000s, we saw the first records of Aedes japonicus and Aedes albopictus. So Aedes japonicus is originally from Japan, and Aedes albopictus is originally from Southeast Asia. So both of these species were detected for the first time during surveillance. And then we see in 2016 records for Aedes aegypti in Canada, and actually in 2019, we see the establishment of Aedes albopictus, one of those species that we detected for the first time earlier in the decade. So as we can see, not only are this species being introduced, they're actually establishing populations. And what this means is they're actually surviving our winters. So this is specifically in Southern Ontario, which is one of the warmer winters that we see in Canada. So it's likely that the rest of Canada will follow suit as our winters become less harsh. All of these species I'm talking about here in this graphic are really important vectors of many mosquito-borne diseases. So with all this surveillance in Canada, Nova Scotia has kind of been lacking. So our most recent survey was in 2001. And actually, since then, we've actually noticed an invasive species in Nova Scotia. So in the year 2000, Aedes japonicus, one of the previous invasive species I talked about in the last graph, it was detected unofficially in Nova Scotia. So this was actually not during regular surveillance. It was actually detected by an entomologist named Jeff Ogden, and he actually just found it by happenstance. He wasn't even surveying mosquitoes at the time. So this is really alarming considering since our last survey, we're already seeing invasive species. So this is where I come in. So for my master's project, I really want to come in and kind of establish what we have here in Nova Scotia. With over 20 years since the last survey, who knows what we have missed, especially when we see Aedes japonicus has already arrived. So my master's research had kind of three main objectives, and I'll just briefly go over this today in my presentation. So the first one, I wanted to assess the mosquito species in Nova Scotia using surveillance. So this is traditionally physical surveillance where you go and collect the mosquitoes. And I wanted to define the habitat features where I found these mosquitoes. And what I mean by that is like, when I detected a mosquito, where did I find it? Did I find it in a natural wetland, an artificial container, a roadside ditch? Did I find it as an adult or as a larval mosquito? And how did this change throughout the year during surveillance? And lastly, I'll talk about invasive surveillance using eDNA for community science to help detect these invasive species. So just for the beginning of my project, I'll talk about the first two as they kind of go hand in hand when you're doing surveillance. So if many of you didn't know, mosquitoes actually have a very interesting life cycle. So the mosquito that we know when we're walking around outside that's biting us, that is actually the terrestrial adult stage of the mosquito. So this is the mosquito that will fly around and bite you, and after blood meal, it will lay its eggs on the surface or around the edge of a body of water. And after a few weeks, these will hatch into larvae. So these larvae live in the water for a few weeks and will feed on detritus, bacteria, and plant matter. And after these few weeks, it will turn into a pupa, which will then emerge into an adult, and the cycle continues. So I wanted to survey both stages of the life cycle, both the terrestrial and the aquatic life stage. So to survey the adults, I used something called the CDC light trap. And there's just a quick video here. And this gas that you see coming out of the trap is sublimed CO2. So I use CO2 in my traps as they act as a kind of universal attractant for mosquitoes. Similar to how we exhale, this is how mosquitoes kind of find their hosts. They have host-seeking behavior, and they can actually identify hosts based on their breath and metabolism. So I use CO2 in my traps to collect adult mosquitoes overnight. And I collected using CDC trapping at 52 sites across the province. Here's a little visual representation of where most of my sites were. And so I trapped from May to October in 2021 and 2022. And I used sites such as public walking trails, provincial parks, as well as public areas that many people encounter mosquitoes at. And then I wanted to look at the aquatic stage of the mosquito, because this is really important since many adult mosquitoes actually can fly quite far from the larval habitat that they were found in. So to really narrow down where you find these mosquitoes, where they're living, I had to collect the aquatic stage. So I used something called dipping, and as simple as it sounds, I used basically something called a dipper, where I scoop water from a mosquito habitat and collect both larvae and pupae, and I ID these mosquitoes to see and classify the habitats that they're found at to really see which mosquitoes we find where. So I collected larvae at about 320 sites across the province, once again from May to October in 2021 and 2022. You can see generally here my larval dipping sites across the province. And I dipped at sites such as roadside ditches and agricultural dikes, permanent ponds, ephemeral ponds, as well as bogs, artificial containers such as discarded tires, and shallow rock pools. So these are all habitats where you traditionally find mosquitoes. So just to go over a bit of the results of my surveillance, I collected over 10,000 mosquitoes during my surveillance over these 2 years and collected 34 species. And of these 34 species, 8 were new records for the province. So these are the scientific names, so don't worry too much about reading each and every one of them. I just want to highlight 2 specific species because they're really important to know that they're here. All of these species are originally from the northeastern United States. So it's most likely that they are being introduced into Nova Scotia through northward expansion through New Brunswick, so traveling by land into the province. The Culex salinarius are mainly found as adults around coastal communities, and this is because their larvae specifically like living in brackish or slightly salty water. So you can see I found it in Grand Pré, the Acadia salt marsh. So this species is a common human biter and is a transmitter of, or a potential transmitter of, Eastern equine encephalitis virus. From now on, I'll call it EEE, and West Nile virus to humans. So it's really important that we know that it's here. And the second species of concern was Culecetta melanura. So similar to Culex salinarius, it can transmit both EEE and West Nile virus, but it's also the most prolific transmitter of EEE to humans in North America. So it's really important that we have identified this here in Nova Scotia. So I found this species quite commonly in actually public parks, such as national parks, provincial parks, and the Victoria Park in Truro. And this species really likes acidic water, and such as from sphagnum bogs, which we have a lot of here in Nova Scotia. And so you're probably wondering, Taylor, did you find these really scary mosquitoes that we've been finding in Canada, the Aedes aegypti and Aedes albopictus? I did not find these mosquitoes. During my surveillance over both years, I did not find a larvae or adult from these species. So it's likely that they haven't arrived yet if they are to arrive. But what I did see was the expansion of Aedes japonicus. So this was this new invasive mosquito that was detected in 2007 by the entomologist Jeff Ogden. So during his basically happenstance routine of surveillance, he found them in 3 counties: Kings County, Halifax County, and Colchester County. So during my surveillance, I found them in all 18 counties, and actually really commonly as larvae and tire, and so commonly that I would say if you found a tire by the side of the road and looked into it, you would find this mosquito. It's wild to think that within the 20 years since the last survey, this invasive species has not only been introduced into Nova Scotia, but has also established and really prolifically spread across all areas of the province, even very remote areas. Another thing I noticed while doing surveillance was that many of the species I collected had really specific preferences for what habitats they would live in. So for example, I'm showing a depiction of 4 of my species and the habitats, the proportion of each collection I found in a habitat. So the habitats being container, ephemeral pond, permanent pond, roadside ditch, and wetland. So for example, Aedes japonicus, that invasive species that we first detected in 2007, has a really high preference for containers. And for containers, this would be rain barrels or plastic containers left out in the rain. Aedes cantator, the one on the left, kind of can be found in every habitat, but mostly prefers wetlands. And Anopheles punctopenis on the right, you can see it really prefers permanent ponds and roadside ditches. And also, I did find that the containers were a hotspot for disease. And what I mean by that is I made this graphic that shows the species richness found in each habitat. And as you can see, although ephemeral ponds and wetlands had the highest richness of species, containers, every single species detected in a container was a vector of either West Nile virus or EEE. And by ephemeral pond, just to classify what that means, it's a pool of water that is goes through periods of evaporation and filling up over the season. It's not permanent. So as you can see, these containers are really kind of a hot spot for many vector species. And it's really good to know this because this is the one habitat that humans have a direct impact on. So with this, we can suggest emptying out any containers in your yard to really help control the vector species that we find in Nova Scotia. I also saw that mosquitoes showed clear seasonal trends throughout the season. So I couldn't go over all 30 species of mosquitoes. So I broke them down into 3 of my main genera out of 6. So here we have the Aedes genus, Anopheles genus, and Coquelictidia genus. So this is from my collections in 2021. I have the amount of adult mosquitoes collected and throughout the season. And as you can see, Aedes species are caught frequently throughout the season. So from early in May to middle of October. And actually Aedes japonicus, that recent invasive that we've seen in Nova Scotia, was actually one of the first mosquitoes I detected and one of the last mosquitoes I detected. So they are here and they're active throughout the whole season. Coquelictidia is actually genus of mosquitoes that is made up of one species called Coccolithidae perturbans. They're really profound they are very voracious human biters. If you're being bit in the evening in June, July, August, it's most likely this mosquito species. And what I saw was they have a very high peak in population. So as you can see, they're quite truncated with their seasonal presence, but their abundance really peaks in the middle. So in 2021, I actually saw this peak in July. And during my surveillance in 2022, I saw this peak actually shift into June. So it's likely that rainfall has a big impact on when this mosquito is present, and that high levels of rainfall actually encourage them to come out earlier. So in 2022, we did have a large rainfall day that coincided exactly 2 weeks before we see this peak shift. So it's likely that they're really dependent on environmental factors. So having talked about my first two objectives, which go hand in hand, I want to focus on my last objective for my master's research, which was seeing if invasive surveillance using environmental DNA and community science for mosquitoes was possible. So you might be thinking, what is eDNA? So eDNA, the E stands for environmental, so environmental DNA. So as organisms live and move throughout their environment, as they eat, breed and move around, they kind of shed DNA into the environment. And the environment could be the water, the soil, or the air. And so we can collect a portion of the environment and actually see what animals and creatures live in this environment, get a whole community and see what is contained in this environment. So what I mean by this is we can collect water, we can collect soil, and we can collect air. So I want to talk a bit more about eDNA and how it's actually applied to a lot of studies. So water eDNA is probably the most common. It's where you collect water, extract the DNA, and see what communities of animals live within the water. So it's really good for doing species at risk analysis. So I know, for example, they used environmental DNA to look for Blanding's turtles in Kejimkujik National Park. It's also really good for detecting invasive species such as chain pickerel, which I know they used to detect in Kejimkujik National Park. Soil eDNA is also really interesting. It's used commonly in agricultural practices. So when people want to look at the health of the soil, they can collect a soil sample, extract the DNA, and look at what microbes or bacteria are living in the soil to really have an idea of what kind of applications it can have for growing crops, for example. Also, they have something called ancient DNA, or where you can look at soil cores and actually see how aquatic communities have changed over time at the bottom of a lake using sediment. It's really interesting to use soil eDNA. And lastly, airborne eDNA. So this is a really recent discovery that we can actually collect DNA from the air. And this is really useful, especially for sampling in hard to reach or remote areas. So for example, in this picture, you have a trap up in the canopy, which is collecting DNA from the air to assess arthropod communities in the air. And also you can actually collect eDNA in the air using drones. So this is really cool. And you can fly these drones to collect DNA. And I also want to talk about two other really interesting examples of environmental DNA. I have footprint eDNA, which I learned about recently. So up in Northern Canada, there's a program to identify individual polar bears based on the snow under the footprints they leave. So they get Indigenous hunters and trappers to collect this snow to send for eDNA analysis, and they can actually identify the polar bear's sex and age. And this is more respectful and less intrusive than the traditional way of doing this, which is tranquilizing the polar bears. And we also have fecal eDNA. So this is where you can use you can do diet analysis of, for example, bats. You can take their feces and actually extract the DNA from that to determine what they've been feeding on. So people actually use fecal eDNA to look at arthropod communities based on bat diet. And they can actually take old fecal samples and actually look at how arthropod communities have been changing over time. So for my project, I wanted to apply eDNA into the water samples I was collecting. So I wanted to see if we could collect water samples from these mosquito habitats and determine what species are present based on the DNA within the water. So just to go into environmental DNA a bit more, I would be collecting water samples and extracting the DNA from these water samples and using next generation sequencing to identify the species within these habitats to get kind of a whole community picture. And the great things about environmental DNA is that it's very quick. You can collect a water sample and send it to the lab and basically use a molecular assay to say, yes, it is present, or no, it is not present. You don't have to do all the morphological identification that I did for 10,000 mosquitoes. It's also quite effective. So a recent study showed that it's just as effective, if not more effective, than traditional larval sampling. So it actually can pick up mosquitoes that you may be missing when you're just dipping alone. And it can also be used remotely. So what I mean by this is, instead of having to pay a technician to go out and sample all throughout a water source or a wetland, you can have take 5 samples throughout this water sample, and you don't have to kind of walk throughout the bush to get to every single little habitat. You can kind of get a whole entire picture without having to survey a huge area, which is really good in Nova Scotia, as a lot of our sites are pretty remote. And because of these 3 great things about environmental DNA, it can be incorporated into community science. And what I mean by this is it can be used with the help of acquiring water samples from the public. So to do this, I created the Acadia Mosquito team, and I hope to use the mail system to help acquire water samples from the public that were interested in helping. So as you can see by this infographic, I had little water vials to collect water, a little collection form to write down the dates that they collected the water, if they saw any larvae, or where they collected the sample, and also just some instructions on how to do it, and a little pamphlet and envelope to send it back. So there are a few hurdles when it comes to eDNA. You might be thinking, if eDNA is so great and using community science is so great, why don't we do this all the time? I really wanted to make this applicable to people who were wanting to help as much as I can. So I wanted to really incorporate it as easy as possible. So I had my samples sent in through the mail. And because I was sending samples through the mail, I kind of had to restrict how much sample size I could commit to being submitted. So I basically agreed on 45 milliliters, which is the largest amount of water you can fit through a mail slot without having to charge for shipping fees. Most eDNA studies recommend at least 1 liter. So these smaller samples can be an issue if it has to, when it comes to maybe low amounts of DNA in the water. The second thing I had to deal with was transportation. So DNA can degrade quite quickly when temperatures are high or when it's exposed to UV radiation. And so once I had these sent through the mail, I really had to consider that, because most eDNA studies, they recommend that you put your samples on ice as quick as possible just to prevent the degradation. And the third thing was inhibition. So a lot of the samples, a lot of the sites that I was hoping people would sample from are not traditionally used in environmental DNA studies. And what I mean by that is mosquito habitats are generally really shallow, kind of murky, boggy water, which would have potentially a high level of organic decomposing content, and sometimes high levels of pollution, such as in roadside ditches. So I really had to worry about these large kind of molecules within the water sample potentially restricting my molecular assay, because most traditional eDNA surveys use open, clear water. So I had to see if this inhibitory effect for my sites would impact my detection assay. And this is really important when considering these habitats, because many invasive mosquito species are actually found in areas with high organic content and pollution, such as discarded tires, which can be full of lots of microplastics as well. So in total, I got 62 water samples collected and 21 from artificial containers. So here you can see on the map the general layout of where I got a lot of these samples coming in through the mail. So it was quite successful. 62 people sent these samples back. I wanted to focus in on the 21 from artificial containers. And this is because these are potentially an invasive mosquito hotspot. It's presumed that a lot of these invasive mosquito species, particularly Albopictus aegypti and Japonicus, arrive throughout the world and can kind of colonize so quickly because they're actually shipped through the international trade of tires. So it's most likely that we'll see them in containers first. So this is why I really want to focus on detecting mosquitoes in artificial containers. And so examples of artificial containers are these plant pots and discarded tires, like I talked about previously. So actually, just to talk about the results of this, it was quite successful. Of the 21 water samples from containers collected from the community, 10 resulted in positive detections for Aedes japonicus. And because I couldn't be 100% confident that the people collecting it knew if there were larvae or not in the samples, I did a same study myself. So I collected 10 water samples from tires with Japonicus, and 9 came back positive, which is actually quite a large amount considering all these kind of issues that I was talking about before, like the small sample size, transportation issues, and inhibition. So I have that little star next to 9 out of 10 because inhibition did play a little bit of a role with my sample. So some sites that I knew that were positive for Japonicus did come back negative. And what it is that the pollution or organic content was just too high to run the sample. So I was able to dilute my sample down 10-fold, 100-fold, and finally 1,000-fold. And what I could actually do is dilute out these inhibitors. So it was actually quite successful to dilute the inhibitors out enough to detect the DNA within the sample. So that was actually really impressive as well. And I think this is because there are so many Japonicus larvae within a tire, usually hundreds, if not more. So the DNA was so high in the samples that usually you can dilute it, the pollution enough to still get a positive detection. So I just want to summarize a bit of my project before I get further into the questions. But I wanted to say that Aedes albopictus nor Aedes aegypti were detected in Nova Scotia, and that was basically the main kind of driving factor behind my surveillance was to just make sure we weren't too late with detecting these species. I also detected 8 new species for the province, and most of, if not all of them, are from northeastern United States, meaning they are traveling northward into Nova Scotia, and this will probably likely continue, that we'll get more species this way. We know that invasive vector species are establishing in tires, specifically Aedes japonicus, and if they're expanding really quickly through Nova Scotia, which is really concerning because both albopictus and aegypti also live in tires. So seeing as Japonicus can establish so quickly, it's likely that these species will establish quickly as well if given the chance. And I've also determined that environmental DNA is a great tool for species detection, and it can be used to sample key invasive species habitats. It's applicable to detecting Japonicus in tires, so therefore it's likely to be able to be applied to detecting both albopictus and aegypti if they are to arrive. And it's a lot of doom and gloom with this invasive mosquito species talk, but what we have to remember is Nova Scotia is in a really good position for surveillance program. Early detection is key for these species to kind of get a public health initiative out there and to protect people. And we currently do not have these 2 major vector species. So if we continue surveillance, it's likely that we're in a great spot. We're not too late, even despite the 20-year gap in surveillance. And just before I finish up, I'd like to thank my supervisors, Dr. Ferguson, Dr. Hillier, and Dr. Easy, as well as all my funding sources, and of course, the Acadia mosquito team. Thank you so much.
Thank you so much, Taylor. What a great talk. So we're now going to move into the question period. So if you have any questions you would like to ask in person, feel free to ask them now, just live, or if you have any questions in the chat, you can also type them in the chat and we'll read them out to Taylor, or Taylor can read them and we'll answer them. So yeah, feel free to ask ahead. And if nobody has a question for now, I will ask one first. So Taylor, this survey, it's great that it's being done. And I'm just wondering, is there any plan to move forward with this in the future? Is there going to be continuous surveillance, or what are the future directions of the program?
Yeah, so that's a great question. So unfortunately, I'm going to be leaving my master's position coming up, but the lab I'm working in, they're hired new master students, and what they're doing is kind of establishing routine surveillance for PEI New Brunswick as well. Because although the Maritimes have kind of been forgotten about a little bit, so I've identified some key areas to keep monitoring in Nova Scotia, which they're doing, and these would be international ports such as Halifax and Yarmouth. So they're continue to survey those areas, and that they're also increasing to PEI New Brunswick. So this is the direction that the surveillance is going. And in a way, surveillance in New Brunswick, BC is almost, if not more important than surveillance in Nova Scotia, because a lot of these species that we're seeing are coming through New Brunswick. So I think as long as we maintain the surveillance in the ports and in the land boundary border, we should be good to go. And that's what the lab is continuing to do.
That's great to hear. So
Awesome.
do we have, oh, yeah, Chad, go ahead.
I was just going to say, amazing job. The presentation looks really, really great. And man, it looks like it was a lot of work.
It was.
Like, and it all seems to come together really well. So you look like you're in a good spot to defend in 2 weeks. So I hope it goes well. And we do have a couple questions from the Facebook world. Someone has asked, how many species in Nova Scotia drink human blood? Or do all of them?
That's a really good question. So not all of them do. So mosquitoes kind of are specified based on what hosts they feed on. And it's kind of like, are they feeding on mammals, birds, reptiles, sometimes even fish? So we generally get bitten by the mosquitoes that feed on mammals. And this is just based on our temperature and our kind of CO2 rate. I would say, I don't know if every mosquito is super specific to the point they wouldn't accidentally feed on this, but I would say at least half of the mosquitoes we have in Nova Scotia do feed on humans, and some more than others. Some are more voracious biters than others. There's some species of mosquitoes that don't feed on any blood meals at all, such as Toxorhynchides ridiculus. We don't have it here in Nova Scotia, but this is an example of a mosquito that only feeds on nectar from flowers. So, but yeah, there's a few that only feed on reptiles and birds.
Very cool. Another person asks, besides removing tires from your backyard, is there anything you can do to deter some of these potentially invasive mosquitoes? Yeah,
so that's a really good question. I don't know too much about every action you can take, but deterring them, there's, I know there's some essential oils. I think it's garlic essential oil is apparently known for deterring mosquitoes, and I think they're looking into lemongrass as well. But just sometimes they just find a way. The best thing to do is just protect yourself. So removing yourself from the outdoors, covering up with bug nets, or using bug spray is kind of the best thing to actually deter them. These guys can be relentless, and it's not always easy to deter them rather than prevent them.
Great. I have a question too. What do you look for on a mosquito to differentiate species?
Yeah, so I have this huge key that's like 300 pages long, but a lot of it is actually their color. So some mosquitoes are really beautiful in black and white and brown, but the main thing with a lot of these mosquitoes is kind of like the bandings on their arms. So Culex mosquitoes, which are mosquitoes that sometimes like to feed on humans, but mostly feed on frogs, they don't have any banding on their legs. Aedes mosquitoes have sometimes white bandings, but it's kind of a key I go through. And a lot of them have scales. So mosquitoes have scales. So depending on where the scale is, the color of the scale, it's very specific. Like if a scale is there or not, you can go down to species. So a lot of it's color and scale.
That's awesome. I had no idea. Now I want to go look at mosquitoes.
Sometimes I can catch them in the air and I can tell just by looking at them.
Amazing.
Mm-hmm.
Okay, do we have any other questions from our audience here? No more questions? Okay, then if there's no more questions, then I would just like to thank you again, Taylor, for a fantastic talk. And again, yeah, I really think so too. You did heaps of work, so much work, over 300 sites in Nova Scotia. That's pretty incredible. 10,000 mosquitoes, over 10,000 ID. Yeah, good job, great job. And yeah, I'm really looking forward to seeing your defense as well. And at this point here, I would also like to thank our sponsors of our weekly seminar series, the Region of Queens, that makes the seminar possible. And also, as always, you can stay up to date with our seminars via Facebook or Instagram and our social media accounts, and you can see what talks we have coming up in the future. And you can also rewatch our past seminars, including this one, on our Facebook Live video, or you can visit our YouTube channel. And we'll be hosting more seminars throughout August. So we're going to have weekly seminars coming up. The next one being by Dr. Ellen Whitman from the Canadian Forest Service. And she'll be sharing with us the historical fire regimes and recent wildfire trends in Canada and Nova Scotia. So a hot topic, not intended, a hot topic that we currently have, and especially this year in Nova Scotia, it's been a pretty big deal. So yeah, I'm really looking forward to that talk next week. That's going to be at 7 p.m. same time until 8 on Thursday again, and you can join us here on Zoom or on our Facebook Live video. And until then, I hope everyone stays well. Thanks again, Taylor. Everyone have a good night and see you again soon.
Thank you for having me.